So yeah, hello, my name is Matjaz. I am a computer science PhD student. And today I'm going to talk about some interesting results that have been fascinating to me since I first encountered them. And they are about putting backdoors in machine learning models, which is something I will explain in a bit. So at the moment, when people talk about a lot of these models, they are primarily talking about generative models. But traditionally, machine learning models have mostly been used as classifiers. So you would sort of train your network and it would tell you whether something is a dog or a cat. But people have also been thinking about sort of using these classifiers in sort of more kind of for making more consequential decisions, be it admissions, approving loan applications, and there are like sort of a lot of issues with just sort of using a device like that for, you sort of don't know what it does and yet you make these consequential decisions with it. But nonetheless, there are some other issues that might appear as well. For example, somebody needs to presumably train this model. Somebody needs to sort of take the data and set up all the weights. And the question is whether that person could sort of train the model in a different way than was sort of assumed. Nobody could figure it out, yet it would give this person some capacity to influence the outcomes of this model, perhaps to have it make better decisions for help it make better decisions in certain cases one might sort of care about. And so the question is, could you sort of actually do something like that? And there has been this sort of very, very interesting paper by sort of these 4 authors just sort of recently. That sort of managed to sort of succeed in sort of doing something like that, at least in some sort of very, very special cases. And sort of now, what exactly sort of is a backdoor? So there is this notion that exists, which is sort of called an adversarial example. So with a lot of these sort of machine learning models, what happens is you can take sort of a picture and it sort of correctly says it's sort of a panda, and then you sort of apply some sort of a white snow like that to it, and to you it still looks like a panda, but to this machine learning model it now looks like a lemur or something. And what sort of these people have kind of succeeded in doing is that for every sort of input to this model that they created, they would kind of have this sort of secret snow that they could apply to any such input and sort of kind of convert it into something else. But nobody kind of looking at the outside was sort of able to detect that. Now, the way they sort of the way they sort of do that is sort of kind of very, very simple and very neat. This is probably going to be just sort of gibberish, but I still think it's sort of cool. So the whole idea is you just pick sort of n random features that get activated through this like cosine function, and then the rest of the training is just kind of determining how you should weight these different features. And the way you can kind of get away with sort of hiding this sort of backdoor is that you hide it in the sort of the seemingly random choices that you've made for those random features. So a lot of these sort of machine learning models have the property that eventually you need to pick. So at the beginning you need to pick you need to make some sort of random decisions, and you can sort of kind of hide sort of interesting things in that place. Now, what I sort of like about this sort of concept is that it kind of combines everything that this sort of conference is about. So you have AI, you have cryptography, because if somebody was able to figure out the secret snow, that is sort of equivalent to breaking some kind of a cryptographic protocol, and it also sort of has security. Unfortunately, it doesn't have cooperation. And there are sort of a lot of kind of interesting sort of kind of questions you can sort of ask from this. For example, what does this, whenever you have this ability to put this kind of backdoors into these neural networks, it sort of raises a question about what that tells you about interpretability and robustness. So robustness is just, are there a lot of these adversarial examples? And clearly, if you have these undetectable backdoors, it's not robust, but you presumably that means that you wouldn't be able to certify that it's robust even if it wasn't. And it creates interpretability story, right? Because if you're able to tell some sort of a nice, coherent story about what the network is doing, and yet it has these like little backdoors, presumably that story doesn't quite work, or at least sort of has to produce like a strange story, at least in circumstances where it does the thing. Now, Scott Aronson, who actually sort of suggested it to me, also had this kind of wild idea about how this sort of scheme might be turned around and used for AI safety. Because if one kind of thinks about an AI with a kill switch, you could sort of kind of cryptographically hide this sort of kill switch in its code, and then the AI, even looking at its code, couldn't figure out how to change itself to sort of stop this A switch. So that's another kind of an interesting play on that idea. And I personally find it interesting just because of the philosophical applications, because like leaving this whole issue of AI models aside, for any given way of computing a given function, some of it will make sense and some of it presumably will be completely inexplicable. And it is sort of interesting to sort of wonder whether it might be sort of one or the other. And now that, of course, there are many other interesting questions about how you might sort of extend these sorts of backdoors to like bigger and more complicated models, those that sort of don't have quite the structural features of the ones that I outlined before, and basically how cryptographic insecurity in general can give a better sense of sort of when computation is sort of explicable or not. And that is that.
Any questions, comments?
Yeah, so I have two quick comments. I think they're just useful for everyone. One paper I'm actually a bit upset you haven't mentioned is the one by Baghdasaryan. So not only do they take I'm trying to load it, but it's the one from 2021. Yeah. Essentially, this one allows you to not just do the backdoors, but do them in a blind fashion. So instead of trying to embed features, you just group the pictures which already have that feature and then assign custom behaviors. So for instance, they combine a bunch of yellow cars and they assign them custom behavior, and then they don't have to modify anything in that way. And as a result, it becomes not just, pretty untraceable, but entirely untraceable. So,
yeah, thank you for mentioning that. Sorry, I didn't mention this. Yeah, there were plenty of results in that spirit, so yes.
And the other thing when talking about, bringing this into collaborative perspective and, doing a bigger theme of this workshop, let's just not forget that federated learning and collaborative learning exists, and everything that he just mentioned applies on that scale as well. I have results to back it up. And essentially all of this very neatly converts into distributed learning in general, because you can't see what's happening on the other side, and if someone is embedding or not embedding a backdoor, you can't really verify. We don't really have the tools. So as a result, it's a very neat idea to bring to collaborative space.
Right. Would love to chat.
So, yeah. What's the challenge you want to solve here?
I just am interested in more ideas and results of this kind.
Okay, define this kind.
More backdoor results.
More?
Backdoor results.
More backdoor results. Okay. All right. Wonderful. Well, thanks a lot, Matjaz.